Hello, welcome to Lecture 1.1. Today we will be translating between words in algebra and evaluating algebraic expressions. Key terms you must know for this lesson are, for instance, a variable is a letter or a symbol used to represent a value that can change. So an example of a variable would be x. A constant is a value that does not change, 5. Any number that has no variable with it. A numerical expression contains only constants and operations. So a constant, an operation, and another constant. There you go. That's a numerical expression. An algebraic expression may contain variables, constants, and operations. So how about 5x minus 2? It is really important that we learn key terms to identify addition, subtraction, multiplication, and division. Addition, the sum of n and 3, or the sum of 3 and n. Both would be written as 3 plus n or n plus 3. Those are equivalent. And more than 3 and 3 plus n. Those are all different ways to say this expression. For subtraction, the difference, that's a key word, of 3 and n, it has to go in that order, the 3 first and the n second. You could also say n less than 3. Think about it. You've got 3, then you've got to subtract the n from it. Or the easiest here, 3 minus n. I think we're pretty good at those basic ones. Multiplication, the product of 3 and n, 3 times n. Look at all these different ways to show 3 times n. Probably the most important ways would be 3n or 3 parentheses n, 3 times the quantity n. We don't want to use this x very often because there will be a lot of variables in algebra and you will get confused with whether it's the multiplication sign or the variable x. For division, that's quotient of 3 and n. It has to be 3 divided by n or 3 over n. We frequently use the fraction bar to represent division. In algebra, subtraction and division, order is very important. It will completely change your quantity. So when I say the difference of 3 and n, it has to go 3 minus n. When I say the quotient of 3 and n, it has to say 3 divided by n. Order is important on those two. So let's see examples of ways to write 9 plus r. I could write the sum of 9 and r, 9 increased by r, or exactly what I just said, 9 plus r. For b, q minus 3. I could say q, 3 less than q, the difference of q and 3, or q minus 3. For 7m, you could write the product of m and 7, or m times 7, or 7 times m, all equivalent there. And for d, you could write the quotient of j and 6, or j divided by 6. You will have to be able to write the verbal phrase to represent the algebra and go in the other direction as well. Once again, here are a few more words that signal adding, subtracting, multiplying, and dividing. And realize in algebra, all these different expressions represent the same thing. We have to pay close attention to symbols when we are dealing with algebra. All right, let's look at some word problems. If I had to translate these word problems into an algebraic expression, I need to first determine what operation is going on. If Eve reads 25 pages per hour, the per hour is a key word in my mind. That would be 25 times h. Once again, you could have written 25 times h, or 25 with the dot and the h, or just 25h. We don't usually write h25. We usually write the number in front of the variable. If Bill is 2 years younger than Sue, let's think about it. Bill's older. So if we know Sue's age, Bill is younger. So if we know Sue's age, we just subtract the 2 because Bill is 2 years younger. So it'd be s minus 2. For C, this is a little misleading. I believe they should have added that we're looking for the rate, write an expression for his rate. Now, I know that distance equals rate times time, and if I solve this expression for rate by dividing by t divided by t is 1r, and we have rate equals distance over time. I do not know the distance. Let's have that be a variable. I know the time is 12, so I would write that m divided by 12 will give me his rate. That's a little more complicated example. To evaluate an expression is to find its value. To evaluate an algebraic expression, substitute numbers for the variables in the expression and then simplify the expression. If I have x is 8, y is 5, and z is 4, I would just add 8 plus 5 to get 13 as my sum. For B, x divided by z, I have 8 divided by 4, which is 2, to get my quotient. You can try these three if you would like to pause the video and then unpause as you are finished. So substituting 3 for m and 2 for n, 3 times 2 is 6. Substituting 9 for p and 2 for n, 9 minus 2 is 7. Substituting 9 for p and 3 for m, 9 divided by 3 is 3. Last example in this section would be that lovely word problem. So approximately 14 20-ounce plastic drink bottles must be recycled to produce 1 square foot of carpet. I don't care that they're 20-ounce drink bottles. I care that it takes 14 bottles to make 1 square foot. So for 14 bottles to make 1 square foot, I would have to multiply the amount of carpet that I want to find times 14 bottles to determine how many bottles I need. Now it gave me 3 separate ones. I'm going to substitute these 3 values for the C. So 14 times 40, that product would be 560 bottles. It requires 560 bottles to make 40 square feet of carpet. So this is my first answer. The second one would be 14 times 120, which would require 1,680 bottles. Wow. So this was one problem. Then the second problem, and there's one more. It asked me for 224 square feet of carpet. I would need to do 14 times 224, which is 3,136 bottles. That is your video for lesson 1.1. I hope you enjoyed this lecture.